Hello, it's me Vince, and welcome back to another set of IB Math Speedruns. So today we're going to go through the chapter review of Chapter 5, finishing Chapter 5 off, and then we'll continue to Chapter 6.1. So let's jump right in. So I guess I'll be doing the odd questions. So first, a co-educational school comprises 15 classes of 30 students, MYP 1 to 5, and 150 DP students. There are equal numbers of girls and boys throughout the school. Describe how you would obtain a stratified sample size of 40 students. Sorry, this is the corrected question, so it's actually meant to say 240 and not just 40. So how would we go about this? We have 15 classes of 30 students, so that will be 15 groups, and then our last group will be the 150 DP students. To obtain a stratified sample size of 240, we need to divide 240 evenly among the 16 groups, and 240 divided by 16 is equal to, should be 15. So we need to pick 15 students at random from each of the 15 classes, and we need to pick 15 students from the 150 DP students. So yeah, that's how we would do it. Okay, on to the next question. Next question is number 3. Give 3 rules to be followed when designing a questionnaire. Okay, well, what 3 rules can we come up with, really? So, obviously, we need to make sure the questions are clear, so that, our respondents can understand them. Make sure that the questions are not leading, so no leading questions. So the questionnaire is as unbiased as possible, and maybe ensure that no options are missed. Because if you miss out an option, it might signal to the respondent that, oh, this isn't here, just pick another one, pick the closest one. And so they pick an option that isn't really their first preference. So those are 3. Okay, next. Next question is, we need to determine which of the following are discrete or continuous and quantitative or qualitative variables. So the first is taste. And this is definitely a qualitative variable. And if we were to quantify it, it would definitely be discrete. If ever, why would you ever want to quantify? I would say, actually, wait, no, is this taste discrete? No, sorry, it's more continuous. Because there's no finite extent to which you can measure taste. You can't categorize taste into certain categories, so it has to be continuous. Next, we have temperature, which is, well, quantitative, unless you want to just give it by, hot or cold. I guess you could describe it like that. And it's also a continuous variable, because there are no, yes, you can measure it to the nearest degree, but it's still a continuous variable overall. Next is cinema attendance, which is a quantitative. And it's a discrete, since you can only measure it to the nearest person. It's impossible to measure it further than that. And finally, height. Height is quantitative, and it's also continuous, since you can measure it to an infinite amount of precision. Okay, so yeah, those are the 4. Okay, next question. We have the English department wish to perform statistical analysis on the first 450 sentences of one of their set literature texts. They counted the number of words in each of the first 450 sentences. And so we are given a helpful table. So we have the number of words per sentence and the number of sentences. So number of sentences, which is the frequency, and then the number of words per sentence. So first, 1 to 10, there were 13 words. And then 11 to 20, there were 16 words. 21 to 30, there are 146 words. Next we have 31 to 40 with 139 words. Next we have 41 to 50, and this is 84 words. Next, 51 to 60, and this one had 32 words. And finally, 61 to 70, which had 20 words. So we need to estimate the mean, median, and modal group. Modal group, and in this case, it's pretty clear. The mode is the easiest one to find. It's just the one with the most, so that would be 21 to 30. So this is the mode. Now the median is actually the mean is probably the second easiest. So we add up all the terms. And remember, we usually get the middle of the class. So in this 1 to 10, the middle would be 5.5. So 5.5 times 13. Plus 15.5 times 16 plus 25.5 times 146 plus 35.5 times 139 plus 45.5 times 84 plus 55.5 times 32 plus 65.5 times 20. So you should get something like 15,885. So if we divide that by the number of terms, 13 plus 16 plus 146 plus 139 plus 84 plus 32 plus 20, we get 450. So, of course, 450 sentences. So if we divide 15,885 by 450, we get the mean words is 35.3. So mean 35.3. So this would fall in the 31 to 40 group, so it would actually be 31 to 40. And the median, well, the middle term of 450 is 225. So we count 225 terms, 13 plus 16, plus 146, plus 139, and we get that it should also be in this 31 to 40 group. Okay, next, estimate the 5-point summary for the table. And this means that we need to find the minimum, the maximum, the first quartile, the median, and the third quartile. The median, we can use 31 to 40. The first quartile would be 450 divided by 4 is 112.5. So 13 plus 16 plus 146. So the first quartile would be in this 21 to 30 group. The minimum was obviously in the 1 to 10 group. The third quartile is 450 times 3 over 4, 337.5. So we have 13 plus 16 plus 146 plus 139. So the third quartile will be in this 41 to 50 group. And finally, the maximum is of course in the 61 to 70 group. So we need to estimate the percentage of sentences with more than 40 words. Well, this would simply be 84 plus 32 plus 20 over the rest. So 84 plus 32 plus 20, 136 divided by 450, we would end up with around 30% of the sentences have more than 40 words. Construct a cumulative frequency table and a cumulative frequency curve. Okay. So our table would... Actually, I should start doing these tables in Excel. So anyways, we have the range and the cumulative frequency. So from 1 to 10, it's 13. From 1 to 20, it's 13 plus 16, 29. From 1 to 30, we have 146 plus 29, so 175. 1 to 40, we have that plus 139, so it's around 314. 1 to 50 is 314 plus 84, which is 398. 1 to 60 is 398 plus 32 is 430. And finally, 1 to 70 is equal to 450. So if we plot this on a curve, actually, let's just get some Google Sheets open. I'm tired of doing this non-super mathematically. Okay. Okay, so we have it here. So we have 1 to 10 is 13. So we can simply put 10 and then 13 to plot this. 20, 30, 40, 50, 60, and 70. So we have 13, 29, 175, 314, 398, 430, and 450 as our points. So if we insert a chart using these values, we should get, well, let's do a scatter chart, and we can have a trend line, maybe not really a polynomial with degree, well, not 8 clearly, maybe 3, no, because it's more of a S-curve. It's not really a polynomial. It's not power series. It's not moving average. So I'll just stick with a polynomial of degree like 4 in this case, even though it's clearly very wonky. Yeah. Okay, so we've done that. Next, we have to extract 5-point summary from the cumulative frequency curve. So the 5-point summary was at 0, of course. This should equal 0 words. Oh, sorry, that's why we need to insert a point actually here where 0 is 0 words. That's why we might be getting some errors. So a chart type, scatter, customize, series, trend line, not linear, polynomial, degree 4. It's kind of annoying that there's no way to like draw a proper one. Like, as you can see, this is clearly not the cumulative frequency curve. The cumulative frequency curve would pass like that-ish. So, okay, if we extract the 5-point summary, minimum is 0. The first quartile which is 112.5, would be at around 30, maybe a bit lower, like 27. The second quartile, which would be at 225, would be at around, say, 35. The third quartile, which would be at 362.5, which would be around there. So that's around the 445. And finally, maximum is, of course, 450. So that would be at around 70. Next, this is a very long question. We need to draw box and whisker diagrams. And I'm only going to draw one. It says to draw two, but if you want to draw the other one, you can do so yourself. So we have our first quartile, second quartile, median, and third quartile at those ranges. So we have effectively an even box. And then our thing extends for 2 more quartiles past the first quartile. So this is our first whisker. And it extends for two groups after the third quartile as well. So actually a pretty fairly even box and whisker. Of course, if you actually use the cumulative frequency options, you would probably get something more realistic. State the assumption upon which the estimates are made. The estimates are made based on the classes having an equal distribution within them. I mean, yeah, in this case, we're just assuming it's the boundaries of the classes, but in the case, if you plotted the cumulative frequency box and whisker diagram, it would be estimating that they are evenly distributed between, and they follow the cumulative frequency curve. And discuss the differences between the box and whisker diagram from the table and the one from the curve. The one from this table, clearly, we have to assume that they're evenly spaced out or something like that. Or actually, no, we just assumed that they were at the maximums at this point. Whereas if we did it from the curve, we would assume some kind of curving relationship where it decreases as we get higher. Yeah. So next question. And the next question is, in an experiment, the following values were obtained for x and y. Calculate y squared, draw a scatter diagram to illustrate y squared against x, and draw a regression line, and finally find an equation relating y squared to x, and therefore y in terms of x. Okay, so I will write the table in Google Sheets because it's simpler to operate there. If you have a graphical calculator, the results should be the exact same. So we have x, y, and y squared, 0, 0.6, 0.5, actually 1, 1.5, 2, 2.5, 3, 3.5. Then we have 0.6, 0.45, 0.8, 0.85, 1.4, 1.65, 2.4, and 2.85. So if you are doing this on a calculator, you might need to calculate y squared by hand. In this case, however, I'm just going to simply square y. So we're going to go b2 power b2 2. And so that's how I'm going to calculate y squared. And we need to draw a scatter diagram for x against y squared. So we will draw that here. And draw a regression line of y squared against x. Okay. This doesn't exactly look like a linear relationship, but let's just draw a regression line. Trend line, linear, and then we can show the label and show r squared. R squared is actually 0.81, which is not bad actually. I'd expect it to be a lot worse, but so that gives our r value as around like 0.9. That's pretty good. And we need to find an equation for y squared. We can do it using this. Normally just get it from your calculator. So we have 2.13x y squared is equal to 2.13x minus 1.17. And so y is equal to the square root of 2.13x minus 1.17. So you should get like, yes, something like that, I believe. Yeah. Okay, on to the next question. So confused. This book is actually quite disorganized. Anyways, first we're moving on to the exam style questions. So first we have the first question. Consider the following set of data: 3, 6, 1, 5, A and B, where A is greater than B. The mode of this data is 5. The median of this data is 4.5. Find the value of A, B, and the mean. Okay, so this isn't bad. Let's arrange all these numbers in order. So we have 1, 3, 5, 6, and then A and B, where A is greater than B. So A will appear to the left of B. The mode of this data is 5, so either A or B has to be 5. And the median is 4.5. So let's just insert another 5 first, and let's calculate the median. Well, the median's 5 in this case. So to make the median 4.5, A must equal 5 and B must equal 4. So those are two values of A and B, and the mean of the data is 1 plus 3 plus 4 plus 5 plus 5 plus 6 divided by 6 terms, so the mean is 4. So the mean is equal to 4. So yeah, pretty simple. Next, we have Sue collects continuous data on the height of flowers and displays it in the table below, which I will put in Excel. So A, state how many flowers Sue measured the heights of. B, find the midpoint of the modal interval. C, calculate an estimate for the mean and standard deviation. And D, Sue's calculator states the median is 25. Find a better estimate than this by considering the median's position within the interval that it belongs to. So first, how many flowers? Oh wait, let me put the data in. So we have height, and then 0 is less than, h is less than or equal to 10. Oh, why did it do that? 10 is less than h is less than or equal to 20. 20 is less than h is less than or equal to 30. 30 is less than h is less than or equal to 40. 40 is less than h is less than or equal to 50. And so this is the frequency: 40, 45, 50, 60, and 5. So state how many flowers Sue measured the heights of. It's simply add up all the frequencies. So 40 plus 45 plus 50 plus 60 plus 5. So it's 200 flowers. Find the midpoint of the modal interval. The modal interval is this, and so the midpoint would simply be 35. Yeah. Next, calculate an estimate for the mean and for the standard deviation. So we just assume that each one takes the midpoint, so mean, we should say a number of terms is 200. Sum of terms is equal to, let's say 5 times B2 plus 15 times C2 plus 25 times D2 plus 35 times E2 plus 45 times F2. So the sum is 4,450, and the sum of x squared is equal to, if we copy this, and, well, we just square all of them. Changing these all to 2. So we should get a number like that. So let's get the mean, which is just the sum of the numbers divided by the number of numbers, so that's 22.25, and then the standard deviation is equal to the square root of the sum of the mean of the squares minus the square of the mean. So we have B6 over B4 minus C4 squared. Is that correct? B6 minus over B4 minus C4 squared. It's actually quite a large number. What is it without the square root? I made a mistake with this formula. I think I've made a little mistake. Sorry, this should only be the first value squared. So this would be 5 times B2. It should be just 25 times B2 plus 225 times C2 plus 625 times D2 plus 35 squared. 1225 times E2 plus 45 squared is equal to 2025 times F2. Oopsies. So yeah, I mean, I think that looks like a better value, so we get 11.6 as the standard deviation. So, get a better median. So the median is roughly 100, and so it lies in this interval here, since 40 plus 45 is 50. So the sum of the terms before this interval is going to be equal to 85. So we only, and at the end of this, so at the start of this interval will be 85, and at the end of this interval it will be 135. So to get the 100th term, well, what's how far along is 100? So 100 minus 85 is equal to 15, and 135 minus 100 is equal to 35. So 15 plus 35 is equal to 50. So it's only going to be 15 over 50, the distance, or 0.3. So it's only going to be 0.3 this class interval. So it should be equal to, I think 23 is a better estimate, since 0.3 times 10 plus 20, 23. So yeah. Next question. So the next question is, we have discrete data showing the marks of 76 students who each took the same IB exam is given in the table below. Sketch a bar chart to represent this data and give 2 reasons why it would not be valid to use this scatter. For this data, find the mean, median, and mode. And finally, explain any similarities between the median and mean using a geometrical property of the bar chart. So let's put the data in. So we have the grade and the frequency. So we have 1, 2, 3, 4, 5, 6, 7, and 4, 8, 16, 20, 16, 8, 4, which looks pretty artificial if you ask me. Okay, let's make a chart. And we need to do a bar chart, and yeah, well, there's a bar chart. The mode is clearly 4, the mean is clearly 4, and the median is also clearly 4. And the mean and median are the same because the graph is symmetrical. If your graph is symmetrical, then the mean will be equal to the median point. That's just how it is. Because the median will be at the middle, and the mean will be the mean value. And if you average a symmetrical graph, you'll obtain the middle value. Hello, sorry, I'm back. And yeah, so let's move on to the next question, question 17. So for this question, we have, lag. Okay, now we have 10 teenagers were asked their age and the number of brothers. Oh, that's messed it up. Oh, okay. 10 teenagers were asked their age and the number of brothers and sisters they have. The data is shown in the scatter diagram below, where X represents the teenager's age and Y represents the number of brothers and sisters that they have. Okay. So let me just draw out the scatter diagram here. And on the y-axis, we have the number of brothers and sisters they have. And on the x-axis, we have their age. So our age ranges from 13, 14, 15, 16, 17, 18, and 19. And this ranges from 1, 2, 3, or 4 siblings. So 13 we have 2 siblings, 15 we have 3, 16 we have one person said 4, one person said 1, 17, 1, 18, 1, 2, 19, 1, and 2. So we need to use this to complete a table, a frequency table. So we have X and Y. And so, well, we have multiple values for certain values, so actually we need to duplicate some values of x and y. So let's just plot all the points on this table. We need to plot, yeah. So here, yep, here. Okay, x, y. First, 13, we have 2, and then 14, well, we don't have any in 14. So 15, we have 3. 16, we have 4. 17, 16 we also have 1. 17 we have 1. 18 we have 1 and 2. And 19 we have 1 and 2. Yeah. So it says to calculate the Pearson product moment correlation coefficient for this data. And I'm going to plug it into this sheet because I would, well, I guess we could calculate it. But I feel like it would, okay, fine. We should probably calculate it. So, how is this going to work? Okay, so sorry, I'm back. So how do we calculate the product momentum coefficient? So fine, before this we've been using our calculator, but now we have to look at the actual formula. So the coefficient is equal to s of x and y over s of x times s of y. And so what is s? Well, s is equal to the sum of the x times the y values of x, y in this case, over n. Sorry, this should be x squared, and this should be y squared, really. But over n minus the two means. The mean of the x and the mean of the y. And for the x values, we have the sum of x squared over n minus the mean squared, and the same for the y values. It's more or less the standard deviation squared. So, oh sorry, so then this shouldn't be x squared. So it's the standard deviation of the multiple over the standard deviations of the individual ones, effectively. So, well, if we want to do this for all the values, we need to get the sum of the multiples and then divide it by the sum. So actually, let's split this up. Let's get the individual standard deviations first. So the standard deviation of x is equal to, well, we have 13, 15, 16, 16, 17, 18, 18, 19, 19. So we know the terms, number of terms is equal to 10. The sum of x is equal to, let's just quickly sum it up. Where is it? It is here. So we have, oh, it's not there. I wasn't scrolling here. Okay, anyways, it's here. So we have 13 plus 15 plus 16 plus 16 plus 17 plus 18 plus 18 plus 19 plus 19. So we get 151 as the sum, and the sum of their squares is equal to, well, what is it equal to? So we have 169 plus 225 plus 256 plus 256 plus 289 plus 18 squared is, ooh, I've forgotten what 18 squared is, so I'll just put 18 squared plus 18 squared plus 19 squared plus 19 squared. And so we should get 2565 as the answer. So the standard deviation of this would be equal to, well, actually, let's just keep it squared. Would be equal to 2565 over 10 minus 151 over 10 squared. So this is equal to 256.5 minus 15.1 squared. So I'm getting 28.49 as the value. So that's for the x. Now let's do it for the y values. Again, number of terms 10, so the sum of the y values is equal to, let's see, 2 plus 3 plus 4 plus 1 plus 1 plus 1 plus 2 plus 1 plus 2. So it's equal to 17. And the sum of the y squared values is equal to, let's go back, it's equal to 4 plus 9 plus 16 plus 1 plus 1 plus 1 plus 4 plus 1 plus 4. It's equal to 41. So if we have 17 and 41, well then the standard deviation of the y values squared will be equal to 41 over 10 minus 17 over 10 squared. So I'm getting 41 over 10 is 4.1 minus 1.7 squared is equal to 1.21. So this is the square of the standard deviation in the y values. So finally, we need to get the standard deviation of the values being multiplied together. So we have the sum of both the x and the y values. Sorry, I mean the product. The product of both x and y values. The sum of them is equal to, let's see, it's 13 times 2, 26, plus 30 plus 64 plus 16 plus 17 plus 18 plus 36 plus 19 plus 38. So that's equal to 264. And since we already have the means, we can simply go ahead and say the sum of the standard deviation of this will be equal to 264 divided by 10 minus the means times each other. So this would be 1.7 times 15.1. Times 15.1. So 26.4 minus 1.7 times 15.1 is equal to 0.73. So we have 0.73 divided by the square root of 1.21, which is 1.1, times this value over the square root of 28.49. And the square root of 28.49 is 5.34. So we have 0.73 divided by 1.1 divided by this. We get our coefficient as 0.124. At least that's what I got it as. 26.4 minus 1.7 times 15.1. Yeah, it's still 0.73. It's a bit weird. I'm not sure. The answer I've got is a bit different, but it's okay. It allows us to draw the same conclusion that the correlation is extremely weak between the two. So yeah, we get that the correlation is extremely weak, and so what is the next thing we need to answer? The next thing we need to answer is, where is it? Give 2 reasons why it would not be valid to use this scatter diagram to estimate the number of brothers and sisters a 25-year-old may have. So the first thing is that the correlation is super weak. It's like we're unsure if there's even any correlation between the two variables at all. Yeah. And the second thing is that 25, if they're 25 years old, it's outside the range of the data collected, so it would probably be an improper justification. because this is extrapolation from the data we have. So yeah. Okay, and then we can move on to the final question. And the final question is, paired bivariate data is given in the table below. The data represents the heights and lengths of a rare type of animal found on a small island. First, calculate the Pearson product moment correlation coefficient for this data. Second, in 2 words, describe the linear correlation that is exhibited. And third, calculate the y on x line of best fit. Okay, quite a tall order. So first we need to calculate the Pearson product moment coefficient. And we can do that by using the formula. Where is it? Sorry, I'm back. So first we need to calculate the Pearson product. First we need the data. So I'm going to put the data into a Google Sheet again. I think it's easier. So we have x and y. So that for 2.4, 3.6, 2.8, 1.8, 2.0, 2.2, 3.0, and 3.4. And we have the corresponding data values 3.0, 4.0, 3.0, 1.7, 2.0, 2.3, 3.1, and 2.7. So we need to calculate the Pearson product coefficient, which we can do again with the formula. Yeah, there was an error in the formula that they gave. That's why I think I got the last question wrong. But anyways, this should be equal to the product is equal to the covariance over the what is this? The deviation of x times the deviation in y. So to calculate this, well, yeah, there was an error. So this is actually, what we calculate this as is simply the mean of x times the mean of y. Okay, I'm back. I figured it out. And there's such a weird error with the book. I don't know. There are too many mistakes. But anyways, what we get is that, oh, why is that there? What we get is that the coefficient is equal to the standard deviation, like normal of x and y, over, actually this is the standard deviation squared over the standard deviation of x times the standard deviation of y. So what we get is, we have, this is equal to, standard deviation of x first. So we know that the number of terms is equal to 10, I think. Oh, don't zoom in. How many columns are there? 1, 2, 3, 4, 5, 6, 7, 8. Oh, there's only 8 columns. Okay, so the number is 8. The sum of the x values is equal to 2.4 plus 3.6 plus 2.8 plus 1.8 plus 2 plus 2.2 plus 3 plus 3.4. So that's equal to 21.2. And the sum of the x squared values is equal to 2.4 squared plus 3.6 squared plus 2.8 squared plus 1.8 squared plus 2 squared plus 2.2 squared plus 3 squared plus 3.4 squared. So this is equal to 59.2. Now, for the y values, we have the sum of the y values is equal to 3 plus 4 plus 3 plus 1.7 plus 2 plus 2.3 plus 3.1 plus 2.7, which is equal to 21.8. And the sum of the y squared values is equal to 9 plus 16 plus 9 plus 1.7 squared plus 4 plus 2.3 squared plus 3.1 squared plus 2.7 squared. So this is equal to 63.08. Finally, we need the sum of the x times the y values. And so this is equal to 2.4 times 3 plus 3.6 times 4 plus 2.8 times 3 plus 1.8 times 1.7 plus 2 times 2 is 4 plus 2.2 times 2.3 is plus 3 times 3.1 plus 3.4 times 2.7. So we get a value of 60.6 for this. And so now we're ready to calculate it. So what we have in the end is we need, it's not actually that squared. It's more of this formula is equal to the sum of the x and y minus the means times n. So minus the means times n all over n over standard deviation of x and standard deviation of y. So this is equal to 60.6 minus the mean of x times the mean of y. So minus 2.12 times 2.18 times 8 all over 8 over the standard deviation. So let's calculate this top value first. So this is going to be 60.6 divided by 8 minus 2.12 times 2.18. So this is equal to 2.9534. So now we divide this entire value by the standard deviation of x times the standard deviation of y. So the standard deviation of x is 5.92. It's 59.2. Oh, sorry, wait, I just assumed. Oh, wait, I did something wrong. Hold up, let's erase this, because that's wrong. Because this should be 21.2 over 8 times 21.8 over 8. So, let's actually just write the mean values down. I think that will be helpful. So the mean value will be equal to 21.2 divided by 8, which is equal to 2.65. And the mean value of y is equal to 21.8 divided by 8, which is 2.725. So this is 60.6 minus 2.725 times 2.65 times 8 over 8. So we have 60.6 divided by 8 minus 2.725 times 2.65. So we have something a lot closer to 0.354. And now we need to divide that by the standard deviation. So the standard deviation in x is equal to 59.2 divided by 8 minus 2.65 squared. So that's 0.3775. times, and then we have 63.08 divided by 8 minus 2.725 squared. So we have 0.459. So if we divide these all, 0.354 divided by 0.3775 divided by 0.459375, hopefully we should get... Oh, we forgot to square root the standard deviations, right? So this should be 6.308 divided by 8. Oh, sorry, 63.08 divided by 8 minus 2.725 squared is so we need to square both of these bottom ones. So if we square root 0.459, we get this should be 0.6778, and if we square root 0.3775, we get 0.614. So what we do get is 0.354 divided by 0.614 divided by 678, and this ends up at so a much more reasonable value. It's around 0.85. So the coefficient should have been around 0.85. So in 2 words, describe the linear correlation. It's strong positive. Yeah, it looks, well, maybe not strong, but moderately positive correlation. And calculate the y on x line for line of best fit. I guess if you really wanted to, you could calculate this manually, but I'm just going to use a spreadsheet instead, or use your GDC to calculate it. Yeah. So while we wait for that to load, okay. So we put trend line in and then use equation, show r squared. Yeah, so r squared is around our value. So we have 0.937x plus 0.242. So that would be the equation I would put in. Finally, there's a small extra part to this question, and it is the fact that some new data is found on a nearby island, and I'll give you the data. And first, we need to calculate the new PPMCC, which I will just use a graph to do at this point. In 2 words, describe the linear relationship and suggest a reason why it would not be valid to calculate the regression line for the combined data. Okay, and so the extra data that we get is we get 2.3, 2.7, 3.0, and 3.5. And the values are 4.1, 1.5, 4.2, and 1.5. So if we extend our graph to include those values, let's see what happens. Generate a graph, okay. And if we put a trend line through it and show the r squared, we see that we have a much lower r squared, actually only 0.071. So if we take the square root of that, we get that r squared is equal to 0.26. So this is weak positive correlation, and it's probably not particularly valid to include these extra points because, you know, they're from a different population. They're from a different smaller island. So yeah, and that's it. So I hope you enjoyed this speedrun, and I hope to see you in the next speedrun. See you then.